Hello, YouTube. This is Umels03. In the previous lesson, we were taking a look at something called a hash table, and we said that a hash table is awfully similar to a hash map, where we essentially have a collection of key value pairs, right? A unique collection of key value pairs where the keys have to be unique, but the values don't have to be unique, okay? But we essentially have a set of keys, and each of those keys is getting assigned exactly one value, and it's okay if two different keys get assigned the same value. But anyway, we said that a hash map is preferred over a hash table. It's a little bit better to work with a hash map in Java, but they provide basically the same collection of methods, of instance methods. So the ways that you can work on a hash table are the same as the ways that you can work on a hash map. But anyway, we can go ahead and remember to import many important classes in Java. And I don't think we'll need the collections or the arrays classes for this video, but you can go ahead and import vector, stack, queue, hash map, hash set, iterator, enumeration, list iterator, array list, linked list, and hash table. So those are in no particular order, but those are about 11 or 12 important classes that we've talked about in the past few videos. So hopefully you're clear with how these work, and you can go back to previous videos if you're not. But anyway, we can go ahead and study this example class. And I've actually gone back and created Javadocs because in a previous video, we said that one of the components of being a good and successful software engineer is to have clear and consistent documentation. And that can not only remind you of how your code works if you haven't visited it for a while, but also if you leave your software engineering company, it would be nice to pass down some notes to future engineers. And that's what Javadocs can do, right? And so what we can do is in the BlueJ IDE, we said there's a drop-down menu up on the top right, and we can go back and forth between looking at the source code and looking at the documentation, right? So I have some static methods in this class, and you can see that I have some clean documentation for them. So anyway, what we can do is, like, for example, with this Boolean f, right? And I also have a description of what the function does, what it accepts, and what it returns. So this would be a completely thorough Javadocs, right? And if you had a static method that didn't accept any inputs, then you don't need to have parameters specified. You would only have to have a return type specified. But anyway, we can go ahead and click on the documentation within the drop-down menu and scroll to the top, and we see an API for our example class, just like we've been studying the API of standard classes by visiting Google and Blackle. But anyway, there's basically a method summary here, and there's a constructor summary, and we said that every class by default gets a default constructor with no parameters in it, and it doesn't do anything. It doesn't assign any instance variables or anything. It just creates an instance of a class, and that's that. But anyway, we have some static methods down here. I think these are a little more interesting, and I've already populated the descriptions of them. And so anytime you write a description underneath a function header, it will show up here in the API, and that's how Javadocs works, right? And we said the other function of Javadocs is in the BlueJ IDE. If you go ahead, I guess we need to compile it before we can run the static methods. So if we go to compile, and then we click on close, and we said that also if you're trying to run a particular static method and you put Javadocs, then they appear here. And that would indicate to your user what the function does so that your user can use the static method properly. But anyway, what we can do is we can study basically that there are 8 data structures that we talked about, 8 important data structures. So with an array list, we're talking about a growable array. It's a subclass of array list, and it's preferred to a vector, okay? But what we can do on an array list is iterator and list iterator, okay? There's no enumeration on an array list, okay? So we were comparing and contrasting iterators, enumerations, and list iterators in the previous video. But what you're going to have to understand is that these 8 data structures have different levels of access to those 3 different types of iterators. And if you go ahead and you go to blackle.com and you pull up the documentation for the ArrayList class, one of the things you'll realize that the vector class provides that the ArrayList class does not is the .elements instance method, and there's no .elements within ArrayList. So hopefully you can see that you can't call a standard enumeration on an array list. But then if we go over to the vector class, I guess now we have one concrete difference between an array list and a vector is that if we scroll down on the vector API, we see a .elements. But the point is that with an array list, you can do an iterator or a list iterator, right? And you could say, well, iterator.hasNext, and then do something with iterator.next, right? And both of these objects are capable of removing elements from the array list on which the iterator or list iterator is based on. And a linked list has nodes linked to one another, so there's some trade-offs with array lists, right? We said that linked lists are better at array lists, better than array lists at inserting and removing elements, but worse than array lists at getting and setting elements, right? Accessing elements by index position or modifying them at those locations. But with a linked list, we can do an iterator, an enumeration, or a list iterator. So I'm pretty sure if we go ahead and go to the linked list Java API, right, we could click on this. And then there's let's see what methods we have available here. So with a linked list, it doesn't actually look like we have a dot element, so we could actually go ahead and take that out, but we just have an iterator and a list iterator. Okay, so hopefully that's clear to you. But then with stacks, we have a last in first out data structure, so it's a subclass of vector, and we can do iterator, enumeration, or list iterator. Okay, so what we're going to realize is that if we actually study the documentation for the stack class, I already have it open. But what you realize in this hierarchy is that stack is a subclass of vector, which is a subclass of abstract list, which is a subclass of abstract collection, which is a subclass of object. But the point is that stack is a subclass of vector. So everything we've talked about that you can do with vectors, you can also do with stacks, okay? But we don't normally think of elements within a stack being accessed by index position. We normally just think about, you know, peeking and popping at elements, but you could technically create a list iterator or an iterator or an enumeration based on a stack, because a stack gets all the methods from vector, and vector has an elements method, an iterator method, and a list iterator method, right? And then we can also talk about queues. So queues are a first in, first out interface implemented by linked lists. So we said that, you know, that a queue is just an interface for a linked list, right? We could study that here, but queue is an interface for a linked list. And we said that one of the implementing classes is a linked list. So hopefully that's clear to you. But with queues, we can only do iterator, okay? There's no enumeration and there's no list iterator, okay? So an array list is different from a queue because it can do a list iterator, whereas a queue cannot. But an array list is different from a stack because a stack can do an enumeration, whereas an array list cannot. But anyway, with a hash set, we have a unique collection of elements as a subclass of abstract set, and it can only do an iterator, okay? Just like with queues, both queues and hash sets can only do iterator, no enumeration, and no list iterator. And if you didn't believe me, you could go ahead and go to the API and study that on your own. And then there's a hash map, which is a unique collection of key value pairs. It's a subclass of abstract map, and you can only apply iterator on map.keyset or map.values, or you can call, okay, and those are the only two things that you can do with a hash map, is if you could say, basically, if you create a hash map and then you say map.keyset.iterator, and you could create an iterator to iterate through the unique elements in the set or through the collection of elements within the values. We can also create a vector, which is a growable array. It's a superclass of stack, and it's a sibling of array list. And with a vector, we can do iterator, enumeration, and an array list. And I guess that's really only the concrete difference between a vector and an array list, is with a vector you can do an enumeration, although that's really not all that helpful, right? Because an iterator can do everything that an enumeration can, and an iterator can do more things. It can remove elements, and an iterator has shorter method names, right? And then we also talked about a hash table in the previous video, which is a unique collection of key value pairs, just like a hash map. And you can apply iterator on dictionary.keyset, you know, on hashtable.keyset. You can apply an iterator on hashtable.values, or you can call hashtable.elements to get an enumeration on the values. So let me show you what I mean by that. What we're going to do is just see some examples here. So I want to try to real quick compare the source code with the output. So anyway, I'm just going to do the data structures function. And then I'm just going to go ahead and pull up the source code, and we can go back and forth. So we're going to create a stack with strings in it called words. and then we're going to push five strings onto the stack. So ice skating is going to be like at the bottom of the stack, right? Because it's the element that's being added first, but then apple is going to come on top of it, and then roller coaster, and then no way, and then penny. So if you say added ice skating first and penny most recently, you could create a list iterator of type string called parseMe, which is based on the stack. And you could say, well, parseMe.hasNext, and then you could just call parseMe.next without doing anything with it. We're not printing it on the console, but we're just referencing the next element without doing anything with it. And then we could eventually get to the end of the while loop, right? And then we could just say get to the end of the stack, which would refer to the element most recently added, right? And I guess if we have the word continue at the end of a loop, it just goes to the end of a loop. So I guess we can sort of delete that, but it'll be parseMe.next, right? And then we could get to the end of the stack, right? And then we could go through the stack backwards, and we could say, well, parseMe.hasPrevious, system.out.println of parseMe.previous. So we're going to say going through the stack backwards. And then if we say system.out.print, so we're just going to say penny, no way, roller coaster, apple, and ice skating. And that's actually the reverse of the order in which we added the elements onto the stack. So basically, if we say words.get of 0 for a particular stack, what's the element at index position 0 of a stack? Well, we say words.get of 0, and we get ice skating. So the point is that when you iterate through a stack, you iterate in the order in which the elements were added, not in the order in which they'd be removed, right? If you wanted to pop elements from the top of the stack, you would call .pop over and over again while the stack is not empty, okay? But basically that would have the same effect as if you were iterating through the elements in the stack in the reverse direction if you were doing it previously. So hopefully that's clear to you. But anyway, we could go ahead and think about another queue, right? So what if we say queue of type string, my queue equals new linked list of type string, my queue.add of apple, my queue.add of banana, my queue.add of cantaloupe, and then we say iterator of type string, queueParse equals my queue.iterator, while queueParse.hasNext, system.out.println of queueParse.next. So I think we've already seen an example in previous videos about how we can have an iterator based on a queue, but the point is that you have to know how many types of iterators are available to you based on the data structure that you're working with. So with stacks, you get all 3. With array lists and linked lists, you only get 2. With queues and sets, you only get 1. With hash maps, you only get an iterator, but you can call it on the keys or the values. With a vector, you get all 3. With a hash table, you can only get an iterator, but you can call it on the keys or the values, or you can call an enumeration on the hash table itself, and that will give you an enumeration on the values, right? So it would kind of apply in a similar way to if you were calling dictionary.values.iterator, but it would not have the remove method. But anyway, we can go ahead and add those 3 elements to the queue and then just print them one at a time. So apple, banana, cantaloupe. We've already seen an example of that. So now we're going to say hash table of type string, string, w equals new hash table of type string, string. So we're mandating that the keys are going to be strings and the values are going to be strings. But we said that the keys and the values in a hash table or in a hash map do not have to be the same data type. And then we're going to add 4 key value pairs to the hash table. So we're going to say w.put of Miss Penning's with vanilla. So maybe Miss Penning's favorite ice cream flavor is vanilla. And then w.put of Mr. Ortiz with Oreo, w.put of Miss Taylor with strawberry, w.put of Miss Stewart with Rocky Road. And then we're going to say enumeration of type string, table parse equals w.elements, while f of table parse, system.out.println of another favorite flavor with table parse.next element. So that's calling basically the enumeration methods, right? So what does the f method do? Well, we say that it's a static method which accepts an enumeration on a collection of string objects and returns true if and only if the enumeration has more elements, right? So it accepts an enumeration and returns true or false, right? And we said basically, why do we have an enumeration that only accepts one data type? Because we said if you call dot elements on a particular hash table, it returns an enumeration on the values. So we're going to print the favorite flavors. We're going to print these 4 favorite flavors, and it's not going to be in any particular order. So we just say another favorite flavor, strawberry, another favorite flavor, Oreo, another favorite flavor, vanilla, another favorite flavor, Rocky Road. So hopefully these 8 data structures have been interesting to you, and that you can also be familiar with the collections class and the arrays class and how we can have multiple methods at our fingertips for working with different data structures and that we can understand when is best to use a particular one. What we're going to do is talk again about the switch block, okay, in this video. So sort of at the beginning of the Java programming at lesson 11 or 12 or 13, we were talking about the switch statement. And we said that the switch statement provides alternative architecture for an if-else block, right? And we could have the output of our program depend on a particular condition, depend on whether something is true or false, or depend on the particular value of an int. What we can do is we can also do a switch statement for a particular character, for the char data type. So we have a static method to show the operation of the switch statement. And we want to show that the switch statement works not only for ints, but also for the character data type. It's like an accumulating if-else block until a break statement is reached. The default case runs if either none of the other cases were true, or if one of the other cases was true, but then you hit a break statement, right? We talked about that in a previous video, but this video isn't so much about how the switch case statement works, but maybe it's just a quick review of it and just adding on the point that you can accept a character. So you could say public static void switch function of char a, and then you could say switch of a. And then we have different cases here. So if we say case q, system.out.println of obtained a q, right? So if the character that you fed in is q, you say obtained a q, okay? But then we say case t, and then we say system.out.println of obtained a q or t, because we said that the switch case blocks basically accumulate, right? So if you got a q, you would not only print obtained a q, but you would also print obtained a q or t. And then you would also print obtained a q, t, or y, right? But then these cases sort of accumulate until you hit a break statement, and then you sort of start fresh. So then you, okay, well, what if a is 3? What if the character that you pass in is the character 3? Then you could say obtained a 3 and then break. And then you could just have 2 accumulations on the % character and on the 0 character and then break. And then you could say default system.out.println of didn't obtain a q, t, y 3% or 0. So that would only run if none of these other cases were true because we had break statements, right? But then we could also have a nested if-else block. So we could have if-else architecture to implement the equivalent output of example.switch function, which is the method that we just talked about. And so nested if-else blocks can be formulated from a switch case statement. It's a little bit more complicated, right? And so if we take this switch case block and we formulate it as far as if-else goes, it's this right here. It fits perfectly on the IDE. But what you would do is you pass in this char, right? We say public static void else function of char a, and we say if a is q, t, or y, if a is one of those 3 characters, then if a is q or t, well, then if a is q, you would say obtained a q, right? But then regardless, you say obtained a q or t, and then regardless of that, you say obtained a q, t, or y. But the point is that you could always go back and forth between an if-else block and a switch block. It's easier to go from an if-else block to a switch block than it is to go from a switch block to an if-else block. And maybe that's why the switch block was implemented, is because, you know, the people who made the Java programming language were thinking, well, people use if-else blocks a lot. Maybe they could do something with a switch case instead. It's a little bit more concise, but it would be harder to go in the opposite direction. So now you have both architectures at your fingertips. So let's go ahead and compare them and make sure that we would get the same thing, right? We're studying this documentation and we can basically just have a collection of nested if blocks and if else blocks, right? And it's just this, it's these architectures that are the exact same here. So then what we're going to do is we can go ahead and try out this switch function and the else function for different inputs and just make sure that we get the same thing. So what if we do switch function of q, lowercase q? So it says obtained a q or t, obtained a q, t, or y. What if we do else function of q? And then we get the same thing, right? What if we do switch function of capital Y? So we'll do switch function of capital Y. So then we're just going to get obtained a q, t, or y. What if we do switch function of a space? So then we just say didn't obtain a q, t, y 3% or 0. And let's make sure that we get the same result if we put a space into the else function and we get the exact same thing. Okay, then there's other things that you can do. You can test it with as many things as you want. So what if we do a 0? What if we do a 0? We just obtained a % or 0. Okay, what if we say a %? So then what if we do a %? So then it says obtained a % and obtained a % or 0. So the point is that you should be familiar going back and forth between a switch case block and also between an if-else block. But the point is that you have both architectures available to you, and then also that you just want to have clean Javadocs, right? Javadocs are really helpful for just having descriptions, right? And just in comments in general, commenting and writing descriptive lines that will help remind you and other programmers how your program works. But throughout these 65 videos, hopefully you've developed an ample number of extra techniques and ideas and examples at your fingertips that you can write more interesting and complex computer programs. So I think that's the end of the compilation. From me, Mozo3, thanks for watching, and please subscribe.